How do you design an experiment? An experiment is a way to answer a question that you have. So first you want to formulate an hypothesis. You do the experiment using good controls. They're very important. Then you make observations, that is the data you collect. You repeat the experiment for making sure that it's reliable. You analyze your data and then draw a conclusion, and hopefully at the end you are able to answer the question. Now, usually what happens during an experiment is that you deliberately impose a treatment on something. That can be a subject, or it can be some object or some reaction, and then you measure a response. And you may have come across the terms independent and dependent variable. The treatment is the independent variable because this is what you decide, and then you measure the response, the dependent variable. Now, one thing to keep in mind is you should only change one variable at a time, because otherwise you cannot tell which treatment or which part of the treatment caused the response. Let's look at an example. Let's say the question you want to answer is, does E. coli grow faster at higher temperature? So then you can pose a hypothesis. If you grow E. coli at a high temperature, then it will grow faster. To test your hypothesis, you then set up an experiment. So you will use identical test tubes that contain media that you know supports the growth of E. coli. You inoculate those with the same number of E. coli cells, and then you incubate all the test tubes for the same amount of time, but at different temperatures. And so the temperature here is your treatment, and so this is the treatment. Your independent variable, and then you measure the amount of growth. And what you can how you can measure this, you have to come up with some way of measuring this. Like the turbidity of the medium can be measured either by yes, no, lots of growth, by just looking at the tubes, or you can measure them, measure the OD at 600 nanometers in a spectrophotometer. Or you can dilute your samples and plate out the bacteria and then look at how many cells were in your culture. Okay, then, so you did your experiment, you incubated your test tubes for 6 hours and recorded your results. So you look at the tubes and you see a little bit of growth at 10 degrees Celsius, a little bit more when the culture was at 20 degrees. Between 30 and 40, you don't really see much difference. 50, you see much less growth, and no difference between your control, your uninoculated control, and the culture that was kept at 60 degrees. If you want more quantitative analysis, you may take a reading using a spectrophotometer, and you may get a reading of 0.2, 0.3, 0.45, 0.43, 0.25, and 0.05. So that would be very consistent with your more qualitative determination just by looking at the tubes. Then you analyze your results. So your hypothesis was, if you grow E. coli at a high temperature, then it will grow faster. And the data that you collected would only support this hypothesis for temperatures between 10 and 40 degrees. So then you can do follow-up experiments. For instance, if you want to more exactly find out where E. coli becomes sensitive or inhibited by heat, you could narrow the range of temperatures. You could look at take a closer look at the actual growth rate by taking time points all along. You could test different media and see whether you would see the same effect in different media, and so on. So I hope this gave you a nice brief overview on how you set up an experiment.